All right. Hello, everybody. Welcome back to the stream. Hope you guys are having a good day so far. Today is Thursday, March 27th, 2025. Hope you're having a wonderful day. Welcome, welcome. It is going to be another day, another data, another grind into Python and learning, and diving into more topics here. What do you know? What's going on, everybody? All right. Hope you guys are having a good day so far. Hey, Mahan, hey, Louise, how's it going? We're at 1.62K subs. Appreciate you guys so much for following along and hanging out with me day in and day out. All right, there we go. Hey, Darko! Welcome! Welcome! Yeah, what's your question, Mr. Darko? How you doing? I hope you guys are having a good day so far. Let's get some tunes going, yeah? I like the stream when it has tunes in the background. It makes it easier to think. Not have to hear myself think. Let's go ahead and get some tunes loaded up here. Hello, here we go. All right. Luis, how code so much with being on chapter 4 or 5 in Crash Course? I've already finished Python Crash Course. I've gotten this question quite a few times, and I think it might be a little bit misleading. I don't know. Should I preface something in the description of those videos? I've already finished Python Crash Course, and I've read through the book already. I've completed already, as you can see. Let me go ahead. This is my YouTube Python work folder here, and I'm up to chapter 4. But I'll show you here. One second here. Let me show you. One second. Here. Yeah, so here, I've already finished all the problems up through the whole entire book. Chapter 3, Chapter 4, 5, 6, 7, 8, 9, 10. 9 had a lot of them, look at that. 10, 11. So I've already finished the book already. That's the first thing I did on the channel. We read it together, and then I'm just going back through and uploading the solutions to those problems because it really helps me to just remember the fundamentals of Python, just a further another reinforcement of those lessons I learned back in the chapter. So I highly recommend. I know it's a little bit easier for me just because I'm kind of making YouTube content. I'm using an excuse of making YouTube content to also study this at the same time. So it's a kind of a win-win. So it might be a little bit more difficult for the everyday person without a YouTube channel or something like that to force themselves to go back and do those problems over again. But the YouTube channel really helps me to be able to go back and enjoy going back and learning those things again, or just refreshing my memory on those basic Python fundamentals and functions, because I'm making YouTube content at the same time for the channel. So it's a win-win. Hey, Tim, how's it going? Darko's question: I'm learning front-end programming now, JavaScript. I'm really scared about the AI thing, and what's your opinion about that? My opinion, honestly, I'm gonna give you my genuine opinion. Now, take this with a grain of salt, just because I've never been a software engineer. I'm not a software engineer by profession. I'm a biochemist by profession. So I can't give, a real solidified example or anything, or I can only just give my 2 cents on what I think is going on. I really think that with the trend of things that's going on and with the social media, the way the influencers, showed the ins and outs of programming, and the relaxed, kind of more relaxed lifestyle it provided people, not whether at work, for the people that were actually working and getting things done, but just the more like being able to do remote. And programmers have been kind of laid back in general, so that's they kind of, I guess, have generated kind of an environment within the corporate lifestyle, kind of similar in a sense, but not too much, because it is stressful at times to get work done, from what I've heard from people. But I know I'm rambling on, but what I really think is going to prevail is those that actually enjoy programming and have a love for programming and coding. It doesn't matter for them. I think the people that are scared of AI taking their jobs are people that actually don't like programming. I think those that enjoy programming welcome AI, welcome what it's doing. Those that enjoy programming are the ones that are building AI because it's helping them find solutions. Programmers have always, from my understanding, sought out to innovate and improve their current situations, and AI is just the next step in that. And I think the people that are scared in their boots and shake and shiver me timbers are people that actually don't like coding and are just doing it for the money and don't actually have a true passion about it potentially. Now, let me know what you guys think about that. I think that, MP3 players came out and, DJs came out, but people still play guitar. People still take guitar lessons. People still, want to be in bands, and bands are coming back. Like, everything is pretty cyclical with humans as well. So, I really think about how people cling to vintage, items and nostalgia. They're not going to allow there's barriers to everything. But like I said, I think those that really enjoy programming for what it is are the ones that are actually making the AIs and the ones that are actually using them, and are those people will prevail. The people that are scared are just the ones that I think are in it for the money and the status or something. I don't know. What do you guys think about that? Hey Tim, dude, what's going on? TVOBO. Hey dude, how you doing? I really appreciate you for coming in. Yeah, Luis, we finished Python Crash Course as one of our first things we did in our learning journey. I got problems with understanding hash maps, aka dictionaries. Do you have any sources which I can use to understand hash maps? Dude, honestly, for real, the best way I've been able to, I've never actually done a hash map myself for on a Leet code problem yet. I've been reading them in the DSA and Python book that we've been reading, but I've never actually done an actual solid take on them. But what I can say is that's given me practice with understanding dictionaries, because I really found it difficult to understand the whole indexing in dictionaries and keys at first. What really helped was actually just working with them physically. I had in my project, the Small Business Manager, the first iteration, I was using JSON, so I was forced to use dictionary notation. So try to think of a quick little problem like loading and saving data on a file. Just run a little script over a piece of file and then run it into JSON and dump it out and load it in, and and then work with the dictionaries that way. I think is really helpful, just to get physical practice with them. Mathematicians have survived the inventions of calculate programs of AI. Tim says W take. Thank you, Tim. Hey, Wing Hong, if you guys are part of the early crew, leave a thumbs up, please, if you could on the stream. We got 9 or 10 people in here. Let's go ahead and leave a thumbs up if you're a part of the early crew. We're going to go ahead and continue on with our learning journey today. I'm going to be diving into some more of our Fluent Python today. Right. Wait, hold on. Here go my books. Fluent Python. There we go. So we're still in Fluent Python here. I've been kind of neglecting the reading the past few days. I don't know, guys. I'm kind of getting a little bit chopped up on the reading. I'm a human just like everybody else. It's tough to get yourself to power through these dense books sometimes. I really just enjoyed the projects, and I'm starting to actually kind of like the Leet code process as well. I'm starting to warm up to it. So, but we've come a long way on these books, you guys, and I really would just hate to kind of quit now when we're halfway done with the DSA, and then we're, like not too far. We're a tenth of the way in here. I think we're on page like 75 or something. We're a little bit further than this. Where were we? We saw that. We saw a match case. We saw that. We saw that. We saw that. Where are we? Let me pull up my notes. There we go. Okay. What are you guys working on tonight? Let me know what you guys are studying. Appreciate you guys being here. Okay, we're on arrays. Where's arrays? There we go. I think we're here on memory view. Okay. Yeah. Memory views. Okay, here we go. Okay, here we go. The built-in memory view class, right? So the memory view class is a shared memory sequence type that lets you handle slices of arrays without copying bytes. Is a shared memory sequence type that lets you handle slices. Okay. A shared memory sequence type that lets you handle slices of arrays without copying bytes. It was inspired by the NumPy library, which we'll discuss shortly in NumPy on page 64. Ooh, if you guys want to get into NumPy, we're getting into that. Travis Oliphant, lead author of NumPy, answers the question, when should a memory view be used? Like this. A memory view is essentially a generalized NumPy array structure in Python itself without the math. It allows you to share memory between data structures, things like PIL images, SQLite databases, and NumPy arrays, without first copying. This is very important for large data sets. Using notation similar to the array module, the memoryview.cast method lets you change the way multiple bytes are read or written as units without moving bits around. Memoryview.cast returns yet another memory view object, always sharing the same memory. Example 2-20 shows how to create an alternate view on the same array of 6 bytes to operate on it as a 2x3 matrix or a 3x2, handling 6 bytes of memory as 1x6, 2x3, and 3x2 views. So from array, import array. Octets, array with the code B, right, for the type code, which is a signed char of 1 byte with a range of 6, so 6 bytes. Perfect. Memory view, octets. So you call memory view on octets. Equals M1. M1.toList gives you all the values 0 to 5 in a list. Okay? We cast index of 2 and 2, 3. We cast a list of 2, 3. So build a new memory view from the previous one. So in example 1 here, we build an array of 6 bytes with a type code of B. in footnote 2, we build a memory view from the array octets that exports as a list. Perfect. In number 3, build new memory view from previous one, right? We cast, but with 2 rows and 3 columns. 2 rows, 3 columns. Gives you 2 rows, each with 3 items in it for 3 columns. 2 by 3. And then M3, M1 cast, type code of B, 3 by 2, 2 list gives you a 3 rows by 2 columns. If we call M2 1 of 1, returns 22, equals 22. M3 1 of 1 equals 33. So 1 of 1, so 1 of 1, so the 3 gets overrode to 22. No. M2, 1 of 1. So M2, 1 of 1, so the 4 gets overrode to 22. And M3, 1 of 1, which is 1 of 1, the 3 value gets rode to 33. So when you do octets, you see this array. Oh, interesting. So you can access the same memory location. Okay, I see what's going on. So even though we are splitting this array into different, subarrays using this cast method, we are manipulating the same memory object. So when we output arrays, right, when we print out octets and display the original array, it gives us that list view of the array, like, right, how we created it. And then it gives you can override the values of the previous made casts, right, to still affect the overall memory object of the array. Oh, my bad. I'll turn it down a little bit. I have the volume on 0, but should I even turn it up some more? Let me properties. Or lay on, so it's on 0 dB, it's on the max. Let me turn up the mic then. How about we go up to, how about that? Yeah? How about that? How's that? A little bit louder on my voice? A little bit there? How about that? Let me know how that is. And go higher to 5 dB. That's 5 dB right there. Let me know about that. Okay. The awesome power of memory view. Okay, so we'll say this. Creating a memory view over an array will allow that array to manipulate form using the cast. To reform its structure using the memory view.cast method. Right, so it's structure using the memory view.cast method. You can all while still referencing the original array in memory. No new Right, let's see how it likes that. Exactly. How is my def? Okay, sweet. It likes it. So changing this awesome power of the memory view can also be used to corrupt. Ooh, an example 221 shows how change of a single byte of an item in an array of 16-bit integers. Changing the value of a 16-bit integer array item by poking one of its bytes. So we have numbers as array.array of type H, which is assigned short, right? Mem_v equals to memory view on numbers. The length of numbers is 5. The index of 0 is -2. Mem_v underscore octet equals to cast of the type B. We convert that to a list, and all of a sudden our values change. So then we go index of 5, now gives us a value of 4, which isn't even in here. And then you print out numbers, and now it's all crazy. So what's going on here? In an example, in line 1, we build a memory view from an array of 5 16-bit integers, signed integers, type code H. 5 16-bit signed integers. So what are 16-bit signed integers? This is assigned char 1 byte. I thought oh yeah, an integer is 2 bytes, which is 16 bits. Okay, right. Integers are 2 bytes. Okay. The mem_v variable sees the same 5 items in the array. The create mv oct by casting the elements of mem_v to bytes, type code B. Now line 4 exports elements of mem_v oct to a list of 10 bytes for inspection. Assign value of 4 to byte offset 5. Note in line 6, the change of numbers, a 4 is the most significant byte of its 2-byte unsigned integer, is a 4 in the most significant byte of a 2-byte unsigned integer is what? Oh, how to change a single byte. Huh. You'll find example inspecting memory view with the structure package in fluentpython.com. Meanwhile, if you are doing advanced numeric processing in arrays, you should be using the NumPy libraries. We'll take a brief look at them right away. NumPy. Hold on, let's ask this. Can you break this down? Yeah, the idea here is that memory view lets you directly manipulate raw bytes of an object in memory. Since a 16-bit integer, short integer, is made up of 2 bytes, modifying one of the bytes can effectively change the entire number in unexpected ways. Let's walk through the example. So we import an array, we create the array, we set it equal to the value of numbers with a type of H for the 16-bit unsigned short, with the values of 258 and 259. 258 in binary is 16 bits represents this value and this. 259 in binary, 16-bit represents this. Create a memory view of numbers. Now MB provides direct access to the raw bytes of numbers. Cast B means unsigned byte. This reinterprets the 16-bit integers as a sequence of individual bytes. Each integer, 2 bytes, gets split into separate 8-bit values. Since 258 was stored as 00001, 00010 in memory, modifying the first byte of the 0th index means the number will change in a way that may not be intuitive. Check the modified numbers. So print to list. Memory view allows direct modification of memory at the byte level. Since array H stores 16-bit 2-byte integers, modifying a single bit can corrupt the stored values. Okay. This kind of manipulation can be useful in low-level programming, but it's also dangerous if done incorrectly. Huh. Alright. We'll go ahead and pause here on the reading. We read for 26 minutes. That's good enough for me. We'll come back on to NumPy next. Right. How do you guys like this book so far? I'm not sure. Anybody know why it's dangerous? Well, I guess if you're accidentally changing like the byte sizes of certain values, then you're modifying memory and you can corrupt things like files or whatnot, I guess. Anyone know? Why is it danger? It's dangerous because modifying individual bytes can corrupt the data in ways many may not be immediately obvious. Since multi-byte values like 16-bit integers are stored as a sequence of bytes, changing one byte without considering the full structure can lead to unpredictable results. Unexpected data corruption. If you modify only part of a multi-byte number, the value may become incorrect or nonsensical. Example, we create an array H with a value of 258. Oh, we cast it to a 6-byte integer, a 6-byte, we cast it to, a 1-byte char, and it outputs a new value. Oh, we modify the first value, and we don't. If 258 was stored as this in memory, changing the first byte to 255 results in a very different number. Whatever this is. Depending on the system, numbers may be stored in little endian, least significant byte first, or big endian, most significant byte first format. If you modify bytes without considering the system's bytes order, I don't know much more enough about bytes to understand all this stuff. Bits and bytes still like. This is just Markdown, so you can just use the file format Markdown. And if you've ever, used Discord, it's very similar to the type of text formatting they use in Discord. In certain cases, modifying memory can lead to buffer overflows or unintended behavior in the program. Pardon me. Lemonade. Yeah, over my head too, right? All right, let's go ahead and shift our focus here. If you want access to these notes, they're on my GitHub. Leave a little follow on the GitHub if you guys wouldn't mind. It's linked down below in the description. I post all my notes on there. You guys can check them out. All right, you know what time it is. Oh boy. Oh. crap. Not this again. Oh no. All right, let's see what we can do here, you guys. So we're going to skip the one that we couldn't solve yesterday. We'll come back to it at a later time. We're going to move on. All right, so we couldn't do this one. All right, we're going to do the same kind of strategy where we're going to move on, just like we did from the merge two sorted lists, and then we're going to come back to it. Oh, binary tree. I haven't done binary tree stuff in a while. This is going to be rough. No. Okay. Oh, gosh. Given the root of a binary tree, return the in-order traversal of its node values. Okay, we got to go back to the notes here, you guys. Here we go. What chapter was trees? Was it 7? No, linked lists. 8? Trees. Okay, we want to look for in-order traversal. Pre-order, post-order, in-order. Number 4. In-order traversal, specific to a binary tree, and visits nodes in the order of left subtree to the root right subtree. Order of traversal using in-order traversal would go from node D to B to E to A to C to F. Binary search tree storing an ordered sequence of elements in a binary search tree. Okay. Crap. So, what do we want to do here, though? Let's go like this. Okay. All right, what do we want to do here? Let's think. Let's bring this like so. Okay, so we have definition of a binary tree. Class tree node. Initialized has a value, a left and a none, a right, sorry. And there's a value, a left and a right. So in-order traversal means that we travel to all the leftmost nodes first. So in this example, we output 4, 2, 6, 5, 7, 1, 3, 9, 8. Okay, so we're given a root. Uh-oh. Uh-oh. I've never really done this before. Better time than now, right? Never really done this kind of thing before. So input is this. Okay, so we're given a root, which is a tree node. So what's our base case? Is if there is no children, right? We reach a leaf. So do I need to have... Whoa, what are you doing? Do I need to have, results and some array out front? Hey, come on. All right, come on. What are you barking at? What are you growling at? Oh, you hear that? The wolf is growling. The wolf is growling. Oh. Oh, whoa, 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 whoa. What you growling at? What are you growling at? Go lay down. Coach Mo, I noticed you're using a MacBook. I'm thinking of revamping my 8-year-old setup and considering a MacBook instead of a PC. How does it handle video editing for you since you do YouTube? Honestly, it's the best MacBook or best laptop I've ever owned. It handles the video editing seamlessly. It's very smooth. It's very powerful. It's very portable, and it's very sleek. It's not using any more Intel chips, which is really awesome. It is the M3 MacBook Pro, M3 Pro MacBook Pro. I've got the M3 Pro upgraded one, not the base M3, not the base M3 Pro, but the upgraded M3 Pro, not the M3 Max. And I have 36 gigs of RAM with this one as well to help out with my stream and my tabs and my multiple everything. Keep it all smooth running with enough memory. And then I have a 1 terabyte hard drive with that. It's been great. I had all the 2016 MacBook Pro, the 2017, and the 2019, and I returned them all after about a week of owning them because they sucked. And I had a PC ever since, and this MacBook finally convinced me to sell my PC. And yeah. All right. So... I don't know. I just don't know a lot about binary trees in order to... I don't know. So, obviously you do like recursion with this kind of stuff. So, what's our base case? So, right? What's our base case? Our base case is when you have no children at all. So, if... root dot right is none and root dot left is none, what do we do? Right, we're going to return back to us talking about one of those like hacker laptops. What are we going to return to our recursive function here? We're going to return the value return root dot value. Okay. No, but I want to append into results somewhat like Richard. He's got the nose of a toucan. Welcome, dude. Yeah, we're solving the we're trying to, but honestly I'm really unfamiliar with binary tree work here. We were able to find the maximum depth on one of the problems. That one wasn't too bad, but this one is going to be tricky. So we need to go from the root. We need to travel down, right? If you have a left, if root, so if left is none, what do you do? In the case where you came back up and you went to this node, you didn't have a left, you have a right. So you take the value. In this case, you hit the 8. You have a left, so you have to traverse left and take the value. But if you have a left, you take it before you take its right. So our base case then is if you don't have a left node. No, you return the value. So you return the value. So then we start here on this node. If root.right is none and root.left is none, return value. Well, that's not the case. We have a left and we have a right. So we're going to go root.left. So we're going to say while root.left does not equal none, we're going to continually say while root.left does not equal none, we're going to continually move root to the left. Root equals to root dot left. So while root.left doesn't equal to none, while we have values to the left of us, we're going to continually cycle down and move our root down to the left. Once we reach a case where left and right is none, we're going to go forward. Now what happens though this is where we're getting crapped. Anybody have any ideas? Let's work on this one together. How about? I feel like we could come up with some good solutions together here. So we want to continually, do we want to continue to cycle down the tree on the left side as long as we have items on the left from the root? So in this example, we're starting here on our root with a value of 1, and we have a left and we have a right. So we do not pass this if statement. We then move to this. We say while there is values to the left, we are going to cycle down and go through them. Are we going to call in order What? I'm jealous, man. Whatever lead you have on me in this, you're going to extend it massively. Work is picking back up, and by the end of the day, I'm shot. I need a different job. Oh, nah, man. You gotta remove the comparisons. We're all in this together. You know, it's you know, if you have that competitive, it is competitive. You know, programming can be competitive, but I'm really trying to just break down those walls and just have fun doing it. And you know, what if your base case was if the current root is null and you just keep calling in order traversal left until that runs out? Okay, so what if your base case if the current root is null? Okay, so let's say our base case. So if root is none, we want to return so if root is none, what do we want to do? So if the current root is null and you just keep calling, oh, so you can just basically just do nothing. Okay, So then while root dot left, we're going to call self dot in order traversal on root dot left. We're going to set root equal to root dot left and continue on. If root dot left, so after at the end of this, you're left with a value. You're going to yeah, dissolve that ego. That's funny you said that. What if your base case was if the current root is null and you just kept calling in order traversal root dot left until that runs out, then call it on root dot right. Whoa! Hey, come on. Come, hey. Stop it. Hey, come on. She knows my girlfriend's coming home tonight, so she's fired up. Hey, stop your chirping. You want out? There, oh, she's locked in. That's why. Sorry. Okay. All right. Hey Edwards, how's it going, man? It's awesome to hear from you again. How you doing? Should I turn up the music a little bit? You guys want it a little bit louder? Let me know. Think of how you can use recursion in order to call every single node on the left of root. So on the call stack, a method returns to where it was called from right. So if you called the method from 1, and 1 calls it on 2, and 2 calls it on 4, that's recursion rule. Think about how to implement. It's hard to interpret in words here. Okay, so we're on the 1 here. What's happening in our thing here? Right, so we're on the 1. Okay. We're on the 1. Root is not none here, so we don't pass this. So while there's values root to left, we're going to call in order traversal, right, on 2, and we're going to call in order traversal on 4. So when do we want to append? No worry. If you want, I'm totally down to do some peer coding over like a Discord call, and if you're okay with talking on stream. Obviously, you gotta set some rules. Gotta keep it, professional and kind and respectful, and just But yeah, I don't have any like mods screening anything. So this way, okay. So, hey Tim. This way, any given method won't call itself on root.right until root.left returns back to it right. So we call it, and then we say self dot in order traversal on root dot right. So while root dot right, you do the same thing after this. Oh, so would you call it again on this new signed root? Hold on. So the way your method would work, call 1, 2, 4. Yes, right? Just like I have here. Call 1, 2, 4. Four has nothing to the left of it, so it returns to 2. Four has nothing to the left of it, so it returns back to the 2. Now the method called 2 calls 5 because that's the right of it, and so does the same thing that 2 just did. So we return the left node back in each case. So once we get to here, so the 4, we called on the 4. It doesn't have anything, so this breaks. Oh, so do we return root here? Oh, so we call, do we do results dot append root value? And now how do we start calling the stuff on the right? That's what I'm confused about. The 4 has nothing to do with nothing to the left of it, right? In this example here, the 4 has nothing to the left of it. So we return it back to the 2. So we're going to say that the left value no, you're not returning it. I think you should just append it to the list. Aren't you passing the list to the method so that each call of the method I append myself to the list call left? Well, I put the list up here in the actual class of the solution. So on these recursive calls, it'll be a independent thing, right? Well, this is gonna be self. So I don't want this to append the 2 though. So this is going to call the 2. What is returned back? What gets returned back? Nothing's being returned back. So what is coming back to here? No, you're not returning it. I think you should just append it to the list. Call this. You think I should say this is equal to that, and then results dot append the left value. Yeah, so if you call 1, 1 appends itself, calls 2, 2 appends itself, 2 calls 4, 4 appends itself. Now root is null, return. The method call 4 is finished with its job now, so now we continue the 2 call left. Right, I mean, okay. But I don't want to append, I want to append the value of 4 first. I don't want to append the value of 2 first. I want to append once I reach a root. Right? So I don't want to append the 1, the 2, the 4. I want to append the 4, the 2, the 6, the 5, the 7, the 1. Right? So if I want to if I call right, four will be appended first because your recursive call is before results.append. Okay, so I think I'm just not understanding the recursive unfolding here. I think it's just a recursive issue for me. So we get the left values and then we append the left values. So then we say, we also do the same thing for right. You don't need while loops, maybe it's what's confusing you. So you say if root right, if root left, then call that. If root right, then call that. Oh, we're not returning a value. Whoops, sorry. I need to end this. No, I don't want to return it at the end. Oh yeah, looping via recursion. Yeah, see, I just suck at recursion. I really appreciate your guys' help. You're awesome. Alex, Coach, Richard, thank you guys. You don't need while loops. Maybe it's what's confusing you. You are looping via recursion. Recursion serves as a loop. It will break out of the loop when root is null. That's why we did the base case, which takes care of that for us. Yeah. Okay. Because usually these base cases, what I've done so far is some value is returned back to that recursive call, and then like you continually add or something. So then at the end of this, how do I just return the results? So if the root current value is none, we just stop. Elif will continually call left if root.left, boom, if root.left, boom, if root.left, boom. We append the last value when there's not any, because this returns nothing back to here. Well, don't I need to... I need to stop and return the value, right? And append that value? If the root.left is none... No, because I don't want to do... So what I want to go root.left is none, and then return the value of the root, because it would be a leaf in this case. But I don't have to. I'm not checking if there's a right node though. If root.left is none and root.right is none, you're on a leaf. You return the value from there, and that's what starts all the appends. Root.left and none is none, return value. We have left value returned, right value returned append. Three ... is not a valid value for the expected return type. Let's say I'm 2. In this case, I refuse to append myself until everything on the left is taken care of. How do I know when that is happening? I call on the left node, on the node left of me, and wait until he finishes. Yeah. See, once this returns, then we want to append not the left value, but root.value. Two, one, two, fun. So this calls root.left. When this finishes, this returns nothing back on these calls. So once this returns nothing back, we then append the value of root.left dot value, and then root dot right dot value. Two, 4, 6, 5. Closer. Output, what the heck? Hey Mahan, welcome back, dude. We're working on this 94 binary tree. We're trying to solve it as a chat here, because I don't know really much about in-order traversal. We've read it in the DSA in Python, but we've never actually gotten any practice with it at all. So struggling through this one. So if the root is none, we call self.inOrder traversal on the left. This will then keep going as long as you have values to the left. Once you come down to the bottom, you return back. This returns back to the 2, and we append the value of 4. So we need to say if root dot right, we're going to call it in here because we need to call the traversal after the append. So we'll take this here and put this here. Root equals root dot left. Wait. Work on a local scape? I don't know, I just am guessing. So you suggest get rid of results here? And then do I have to add in a parameter here to pass in with results? Do I have to say like it's gonna be a type integers. Oh. Okay, so results, oh my gosh, it's a list of ints, right? So if root dot none, if root dot left, call this pass in results. We pass in the current value of results. I don't know how to. So passing in results, which is a list of integers. Oh. You can use a local variable, not an argument. So do it here within the function. Do we want to return results then? Right, which is going to be empty at first. This will return a value back to us of the results, an empty list. If the root has a right, we call X5. Should I move this out like I had before? Three, 2, 6, 5. No. Got any ideas, Mahan? Back-to-back days of struggle. Tough luck for us here. Can I just return an empty list? Back, which is results, and append to it. Are you working on it too, Mahan? No worries. So if we're gonna stick with returning none back, right? So we wait for this to finish. Once this finishes, if there's a root to the left, we call this. This will continually call this down to here. Once this finishes, the 2, it returns back to the 2, and we append the root dot left dot value. We append the 4. If root dot left, we call this. So then let's take this out of here. Put this outside of the if statement. We call root dot, so we don't need that. If, call this. Wait for it to finish. When it finishes, then you append the value. 2, 2, 3, no. So we need to be returning a list back, I thought, right? So if we return a list back, this returns a list back to us, and we append I was appending the left root because I thought in this example here, if we're on the one, we call recursive. If it's none, it returns back and breaks this loop. So it returns back to the 2, and we need to append that 4. So if we're on the 2, we have to append left.value. Extend. This dot extend. Root dot value. Extend root dot value. So then I return this back. If you're at the 4, well, if you're at the 4, right, you get called, the root has no left or right, so the root is not, so if root, okay, got you. Okay, so it's saying that the root is not none here. We're not calling left or right. Well, I don't have, I'm not appending anything to this, so I need to do yeah, if we're at none, we immediately return a list. If root.left, if root.right, else. So we need to do, so the 4 doesn't have a left or right, so we have to append it now. You are not in recursion to need left or right. What? So if we're on the 4, you don't have a left value and you don't have a right value, so you have to append. So you don't get hit with this, you don't get hit with these. So you move down here and you're trying to return results here, and you can't. So what do we need to do? and append self, and then solve for the right subtree. Because this isn't going to return anything at the current moment, because I'm not even appending my, I'm landing on the 4, and yeah, none type. Because if I'm on the 4, then I'm not appending anything anywhere here. So else we need to do results dot append root dot value. Okay, and then we return that value back. None type is not attribute extend. Well, this is going to be none type, right? Still. I don't really know, coach. I'm just trying to figure it out. Just trying a lot of different things. Why extending root.val after the right subtree, but if itself goes before right? Why are you extending root.val after the right subtree? Because, so, if I call left here, I call left on the 2, I end up on the 4 node, okay? The root in this case, which is the 4 node, is not none, so I don't return a list. I don't have any left values, and I don't have any right values, so I have to append this 4 somewhere. Now, do I append the 4 after this recursive call? So let's do this. And do we want to return this back? And do we do the same thing down here, but for right? What I'm saying is let's append ourselves once. And that is before left and before right and after left. We are essentially performing 3 actions. We call left and let it take care of appending itself. Then we append ourselves. Then we do what I want with right. Yeah. So I'm still getting none type. So oh, I don't want to append this. I want to call it all the way down, append. And then, so I'm getting null now for everything. Oh, so I don't want to return here. I want to return at the very end after the right call. else return results. If there is no right. No, still. Shoot. I'm giving Ashton Kutcher, Gina. I hope not. You guys a Diddy party goer. Mahan says, Mike, you add left, so left reoccur till you hit something that has null. So you have to go back and add the root and then recur again. So right now I'm just returning null back. So if root is none, we're returning this. In this case down here, root is none, so we're returning that, okay? There's also if root.right, you call that. Do we not return here? Do we return at the very end? 1, 1, 1, none. Ah! So we wait for this to run out. Once this runs out, so in this example, let's just walk through this. Okay, we call in order traversal on root 1. Okay? So we call IT on 1, right? What happens here? Is root none? No. Is there a left? Yes. So we're going to call in order. We're going to call IT on the 2. Right? Then this says, is it none? No. Is there a left? Yes. So we call IT on 4. Is there? Is it none? No. Is there a left? No. So there is no more left. So in this current stack, our root in this current stack, if I was to know there is no left, if root dot left is none and root dot right is none, do we okay, so if root dot left is none and root dot right is none, we're going to return results dot append root dot value, because it's not getting into these things. It's not eval. So we have to say if it's not left and not right, then we're going to return results.append. Or we can just do this, return root.value here. So now root.value is returned back to here. So this is going to be results is equal to this, and then we append the current root.value. If there's a root.right, we do the same thing and append and return results at the very end. Oh, dang it. A dot append is mutating, so null return. You should append first and then return the result. Okay, so, okay. We're returning root value into the results, and then we append the result. Think of when I have to add it. So I add it when there is a leaf. In this example, on 1, 4, 2, 6, 5. Do you add when there's a leaf? When there's a leaf, you add its parent. You go to the next leaf, you add its parent, the next leaf, adds parent. Here, oh, there is no parent. Huh. I tried, I don't really know what to think, to be honest. So, why is this not shifting over? What's going on? Well, I'm drawing stuff here and it's not working. So, we call in order traversal on the 4. Is it none? No. Is there a left? Okay, so we don't even need this. Take this. If root this, if root dot that, do that, elif. Else, which means you have both of them. Return. You don't have any of them. You're gonna return this root dot value at the very end. So if there's root left, you append each time it's given back. Do you append one more value of root? one more time at the very end. Oh, else, so this doesn't get better. So do in order traversal, solve the problem for the left subtree. Add the root, solve the problem for the right subtree. We just have to add root here in between. So if root dot value append no, because I'm doing that in the return. I've been doing that through this picture, Mahan. It's not really getting the job done here. I'm just trying different stuff. I've been walking through this picture over and over again. I just don't know how to get there. So we go from the 1 to the 2 to the 4, back up to the 2, down to the 6, to the 5, to the 7, back up to the 1, to the 3, to the 8, no, 3 to the 9, to the 8. Because you have a left node there. So if there's no left node, you append. So if there's no left node, you append here. If left. Results was not associated with the value. So results is inside of here. So do we have to keep a results to here? If root left, results is equal to this. So we have to keep that if root dot left is none and root dot right is none. We're going to return root dot value here. Ooh, key stuck again. Come on, get out of there. My caps lock key is stuck. Come on, get out of there. Gosh, dang it. Come on. Okay. No. Okay, whatever. So if the root dot left is none, root dot right is none, we return root dot value within an array. This gets sent back to here as results. We append two results, and we return results. If I can type. So it's still. This returns a list back, which is results. We append. So do I have to have a results is equal to an empty array here? So I can at least capture it and then it'll stay. 3, 3, 2, 1, 9, 8. Dang it. Dang it. So you need a single recursive execute thing. Results var only lives within the local scopes of a single recursion execution. Yes. I think this is what confuses you. Yeah, so how can I return the results back to me then? So I'm returning the current root value inside of a list back to this function. So do I need to return results? I didn't merge them. I didn't merge them. So what lines do I need to focus on here? Yeah, so at the end of the call, on this example, the value of 4 is being returned back to us in a list for this value here. So results will be a list with a value of 4 inside. So you need to capture them when you call IT and merge with your results. Right, so results is here. We override the current value of results. So I just concatenate it with results. And then append the new value. Closer. Closer. Oh, spitting over here. We're getting closer. So now we're just doing it double fold for some cases on the way back up. So do I remove these two? Bada bing, bada boom. Bada bing, bada boom! Mr. Wild, step in the room. I'm a hustler, baby. Y'all already know. Pitbull worldwide, wanna step in the room. Yeah! What did that take us? Hour 45? Good God. Sorry if I just blew out you guys' ears. Got it. Leet code today keeps the doctor away, boys. Leave a like on the stream for that one. Woohoo! Is my volume blasting your guys' ears? So I can turn down my mic. Let me know. I appreciate you guys' kind words. Thanks you, Prax. Thank you, Snags. Thank you, everyone, for the help. Mahan, Alex, Prax, Snags. Where's my boy at up here? Where was he? Coach. Thank you guys so much for the help and patience on that one. That was a community effort coming through on that one. I think you can remove all ifs if you want to make it shorter. Remove all ifs except the first one. Sorry, what do you want me to do? Remove all. Like literally like the if statements and just leave this results plus equals. Bruh, no way. It's that much easier. Golly. Okay, so why? Why is it that much easier? So let's walk through this. So if root is none, we return an empty list. Else we create a list at this stack level and we append to it all of the values that come out of this traversal. We append the root of the tree, of the subtree, and then we go to the right side. Oh my gosh, it's so much simpler when you see the answer and you break it down. Golly. Right? You created a local level results of this stack. You, at the end of the recursive call, you append the last result to the left. You append the root value of that subtree, and then you go to the right side. It's so much easier when you look at it with the results, with the answer. You're like, ah. Oh. It's literally like reading English now. Dang. Yeah, because you call root.left all the way until you get to none. You return back this. You return back this. So can you return just nothing back? No, you have to return because this has to be a list to combine with the list. So you return a list back which comes in for this value here. You add onto it results, which is a list that's empty. So in that first pass, you're concatenating an empty list and an empty list. You're appending to that list a for. You can't do this, so you return that value back, which gets sent back to here and to here for some of these calls. which is the 4 in a list. It's not none, this is not its parent now, and you add the parent. So you're just adding the parent, adding the... So this, I want to know like the step by step. So we're returning an empty list back after we call recursively root.left until we reach a none node. Once we reach a none node, we return an empty list back for this value, and we add it to results. Well, results at that recursion stack isn't also an empty list. So we're concatenating two empty lists together, appending the 4 into the empty list, and then calling root.right on it. There are none, so we return that back. This gets returned back to the calls of the parent of root.right, which had these. So in this case, it got called back on the 2. And we add the 2 and then the 5. But the 5 has a left value. So the 5 gets called left on to the 6. The 6 gets called left on to none. We concatenate an empty list with the current value of 4 and 2, and then the 6 gets added here, right? The 6 doesn't have any right numbers, so we return a list back of 4, 2, and 6 back to the root of 5. The 5 has a right value. The 5 gets appended here, but has a right value. So that gets called an appended. Oh, geez. Yeah. I'm trying to just like visualize these stacks, and it's pretty difficult. Like even with terms of like writing it out, like it's hard. This is like one of the hardest concepts I've had to learn so far is recursion, honestly. An honest beginner point of view. Each recursion, you just merge them corresponding to the graphs. So it can be left, left, root, right, root, right. Okay, cool. Let's move on then. All right, this is the project that we've been working on, you guys. We've been working on this one for like a week now. Appreciate you guys being here and joining me. Okay, so this is our current project. So I had a couple like an hour at the end of my day at work where I wasn't doing much, and so I pulled out the laptop and I started coding. And so I was able to start to convert the expenses tab into a working tab like we have for the inventory, like we did yesterday. So like in the inventory tab, we are able to add, I also have messed with these spacings a little bit. Because it was all crammed up right here, I decided to also, I followed the layout of the transactions tab and shrunk the search down, and then just elongated the commitment, right? Like commit expense, commit item. Right. So that's pretty cool. Now what we're dealing with though, and what I also added, I'll show you guys this. So what I also added here was this business class. So what we're going to do is similar to what we were doing in the previous iteration, V1, rip V1, a moment of silence for V1 in chat. So what we did last time was that in the last iteration, we were reading from JSON before. Now, I don't need to have a database for this using SQL because I'm not, categorizing things in terms of a matrix. I just need to basically house some basic information like some lists and some variables just in terms of a file. So I figured I'd just use JSON for ease ease. And that's how we're going to handle the business. So the business class, right, has a name, a categories, and methods, right? If the name is provided, we're going to declare the name, right? Else we'll say that the name is business, and we say that the categories is equal to a empty list so I don't need this, right? The categories is empty list for now, and the methods are just cash and credit for right now for the business. So we'll make these. Yeah, so now, and then we have this function I wrote for read business, where we try to open the business info.json as read, and then we read the content. We say for key value in content, we match the case of name for the key. We set the value to the name variable that we declared here. We set the category to the category variable that we declare here, and we set the pre-existing method value to the methods variable here. So this is basically just reading previous data for these if the user has any overrides, and we'll populate them on launch. Except if the file isn't found, like it's the first time, then we open it and just dump in a blank dictionary. Then we save, which just saves as right in the form of a dictionary of this business, right? Cool. Easy enough. So now that that is taking place, this is what that looks like, is we have this going on now, where we have a dictionary for JSON inside which we have name, categories, and methods, business, default business name, blank list for categories, and a list with cash and credit for methods. So what I did was, in order to initialize that, is I nested it within my small business manager class. So I created a business instance, right? I imported business here, and I created a business instance within this small business manager TTK window, Tkinter window, and then I called business.read business, and then I called print. Right? So now, as you can see here up above, right here is that print that happened when I press play. So it's capturing successfully, reading from the file, the business's name, the categories, and methods that were saved in this business. And so what we're doing then is we're calling self.title, which is the method associated with Tkinter to create the title of the window. Self.title, we're taking the small business manager colon the business's name. So now the business's name will be displayed up at the top of the window along with the small business manager header. And so that being said, is in our settings, we can now allow the user to update and override these values for the name, the categories, and the methods, and they can be able to, populate new expenses off those and whatnot. So it's pretty cool. So what we're gonna do is in our expenses tab. So I also went through this expenses tab and started adding in all the functions, pretty much copying over almost our previous tab in a sense, and just kind of tailoring it to the expense. So this is what we currently have for the app so far, right? So we have the inventory tab that we worked on yesterday. I stretched this out and made this 2/3, 1/3 versus half and half, so that the search commit is the search is 1/3 and the add with all the entries is bigger. So you can add items, right? And then now we have expenses, where you can add individual expenses. Now the only thing I haven't done yet is I haven't done the verifications over the categories or methods. So we have to do that now here. And also import those methods, right, that we have from the business. So let's go ahead and take care of that here. So we are currently using the business class that houses all of our information, which is being passed into the small business manager window. So So do I have to pass in the, because we're creating the business here on this instantiation. Thanks, Avinash. Have a great night, dude. Thanks for stopping in. So we're initializing the business here. We're reading, and then we are changing the title. So then how can I set the business information? How can I set these within the expenses tab? Right, I'm only importing here. We're adding saying database, passing in the database. So I might have to pass in the business, right? So if I go up here, right, I pass into the expenses tab, the business equals self dot equals app dot business, right? We pass in the business instance. Can I access app within here? I don't think so. No. No. Can I do parent dot business? Because I'm getting a parent, which is tab control, which is in the notebook, which has a parent of app. Okay, so we're passing in the business. I say self dot do I want to say self dot business is equal to the business, or do I want to just access whatever was passed in? I guess yes. So self dot business is equal to business. Passing in the business variable. Okay, we then will say business dot categories So here in the categories, this is going to be self.business.categories. Right, and then the methods is going to be self.business.methods. So if we run this, okay, no errors, expenses. Oh yes, we got it. It works. Yay! Look at that. Okay, because there are no categories, right? So let's go over here and let's save some categories in there. Let's go. All right, let's go to business class. Some default categories are. What are some default categories for expenses? Like equipment, shipping materials, right? shipping materials. Oh, so expense would be shipping, right? You have a shipping expense. You have a delivery expense category. You have shipping, delivery. You have transportation, right? Whatever, just for a couple for default. We'll just do these three for now. Okay. So now if we quit that, run here, credit cache, no. Huh. So this is creating a business on launch, and it's reading business. Oh, so let me go here and go business JSON info. Let me delete this. And now let me run. So now we get a business JSON info that's blank. Right, and now when we clear, nothing saves. I'm not calling the save, so I have to call the save on the exit when you quit, but I'll just have to put it here for right now. Move to event on exit of the program or other. So now if we run, it'll save up front. There you go. So now we can delete that. Or we'll comment it out. All right, we need to move that save to some other point in time because now we're getting it there. And we're getting it saved. So if they, right, this would be moved to event on exit or settings changes. Yeah, right? Bro cooks useful projects, gets cooked useless Leet code. Well, some people would say the Leet code is useful, right? Because they get jobs with it. But I'm much better at projects, right? I don't know what it is about the Leet code, but I don't know. I struggle with the overthinking of it. I go into it thinking like it's a lot harder than things are and more lines of code is needed. Oftentimes it's not the case and I just confuse myself, but I get there no matter what. But with these projects, I'm pretty good about like thinking of ideas and then just saying, all right, let's go put it in, because like I really don't know why. It's really strange. I'm like, okay, I want to now, load in the business. How can I do that? Well, let's just pass it in and let's just, pass it in and make it a self argument and then start editing the stuff. And so I don't know what it is, but it's crazy. Yeah, you're right, Mahan. I cook this, but I get cooked in Leet code. Right, so now we have this going on. Cool, so now we have this. Right, expenses. Right, the categories are now being populated from our business file and our business class, which is really awesome. And now we can go ahead and do queries. So we have to add the check category and check method though. Right, so in my expenses tab here, I'm calling during this add expense, I'm calling two functions I haven't wrote yet, check category and check method. I mean, these aren't super like needed because we are putting in the values from the file of the categories and methods, but You know, I because these would be in our auxiliary functions. And we would have to import the business instance. So I don't need these. It doesn't make sense to have these because we're loading in conditions on a file and the user can't edit their own. So there is no point in checking. Right, we do a check duplicate expense given this information. Right, which is in my here. Check duplicate expense. Select where date, description, date, description, cost, category, method equals that. Date, description, cost, category, method, fetch all, if duplicate, return, else return false. Okay, so let's try it. Ready? Here we go. Let's add our first expense into the system. Anybody want to add it? Let's make this the Mahan expense. 03-27-2025. Description, Mahan. I'm not going to type out that last name. Mahan Noir. Cost for this guy, we'll say $18.76, just for some decimals. Category, we'll say is equipment. Method is cash. Note, there is no note. Ready? Add expense. Invalid date. Oh. Add expense. Yes! Woohoo! Big back Mahan. All right, success. We added in the expense. Look at that, guys. So now let's try to add in a duplicate. Let's see if that works. Ready? Value error. Okay. Shoot, so in our OxPy, our check cost, our cents to dollars, entering the cents given. What? We're calling it on duplicate index 4. Oh, I'm calling it on the wrong index then. For cost. Category is getting hit with it. So value error, equipment. So I'm calling the check duplicate, which is here. Just trying to add. Invalid literal for int base 10 with equipment. Cents to dollars on line 251 of populate matrix via duplicate. So this is trying to convert index 4. So let's go to our database. Expenses 0, 1, 2, 3. That's why. One too far. We got it. We got it. So this is index 3. So it should have got, it might have gotten in there. No, it's not in there. Okay, let's go back. Exit this. Run appy. We're in. Okay, let's go expenses. Let's add in the duplicate here. 2025-03-27. Description. Mahan. Noor. Cost. 1876. Category is equipment. Cash. Oh, they can override these values. They can type. Ah, weird. So I do need to check there. Dang. Okay, let's add. This shouldn't be allowed. Ready? Oh, shoot. Okay, we have another bug here. Expense tab on line 251. Right here. No, 252. This should be expense inventory matrix, expense matrix tree. Expenses matrix tree. Add expense status. Okay, ready? One more time. Here we go. Third time's the charm here for Mr. Mahan's expense. Date 2025-03-27. Description is going to be Mahan. Noor. Cost 1876. Category equipment. Method cash. Note none. Add expense. Ready? This should be the duplicate. Ready? Yes! Failed the duplicate, and it repopulated the matrix. So if I go ahead and just change this slightly to make this $20 and add this expense, it'll add, right? But then if I change this back to 1876 and search, it'll repopulate with just this guy here. Okay, so now we need to do the conversion though. So on duplicate. Cents to dollars. Duplicate 3. Okay. Now that should do it. Expenses, Mahan Noor. Now if we go date 2025-03-27, description, Mahan Noor, cost 1876, category, equipment, method, cash, add, duplicate, 1876. Sweet. That looks awesome. Now we refresh, status refresh, and it populates our matrix again. So now let's search. ID. Did I add this in yet? I don't think I did. Expense search. I did. Call found item fetch return on the found items. Okay, so now does our database have that? Add expense to expenses. Check duplicate. Fetch expenses, expense search. Fetch expenses, expense search. Okay, yeah. So now if we open this, can we go ID is equal to 1 and search? No. Line 58. Oh, we're doing it again. Line 262. Should be 3. 3. Okay, expenses, search, ID 1, search. There you are. Nice. Status success. Refresh. Status refreshed. Let's go date 2025-03-27. Search. Success. Expenses found. Perfect. Those are all on the same day. That's why. If I do 25, search, none are showing. No, failed. No items found. Refresh. If I go description, if I type in Mahan Noor, search, success, expenses found. If I type in an S, search, no expenses found. Perfect. If I go cost equals to 1876 and search, success, expenses found. There you are. If I go cost 20, search, there you are. Nice. Refresh. If I go category is equipment, search, there you are. If I go, what other categories do I have? Shipping, search, there are no shipping expenses. Perfect. If I go method, cash, search, found. If I go method, credit, search, failed. So I do need to add in these checks though, because the user can override these values in here too. And then note, if I just delete this and search for no note, failed blank entry. Failed, no items found. So you can't search for no note, blank notes. So we'll say this. We need to allow for blank notes to be searched for. So in our expense search here, if column or if value does not equal to quote hold on you guys. Hello? All right. I'll be right back. I'm gonna go help my girlfriend load in her bags real quick. Give me 1 second, you guys. 1 second. back, suckers. How's it going? Let's keep the vibes going. Appreciate you guys for being here. You guys are awesome. Okay, so, right, if the column is equal to or column if column is equal to that and value equal to that, okay, or if column is equal to, quote, categories and value Why didn't the TV turn on? What the heck? The dog turning on the TV. What's the dog doing? You turning on the TV? Oh, my bad. Bathroom signs up. So, if column is equal to a blank string and value is equal to a blank string, raise a value error. Right? If they're both equal to blank strings. So if the column is blank and the value is blank, if either or you raise the value, if both of them are blank, or the column is blank, you raise a value error. Or or not column.
To the Caribbean coast of South America, visitors can enjoy birding throughout the year.
So if column equals a blank string, or column and value equal blank strings. So you have to have a column no matter what. You have a column and value are blank, then do that. But you can have a blank value to do a search on a, right? So if we go here, run, expenses, if we go here, search, failed, blank entry, but I go search, note, success, found, refresh. So if I add in one with the note here, let's go here, date 2025-03-27, description, test, note, cost $10, category, equipment, or we'll say shipping, method, credit, we'll shake it up. Note is going to be test, add expense, like I added there. Now if I go note, test, search, there it does it. Okay, perfect. So now we can search, and then can we search for blank notes? Yes, we can search for blank notes. ID is blank search, item failed, search, invalid date, search, just no items found with blank description, search, failed, category, search, no items found, method, search, no items found with no method, note, blank, search. We have categories, note, right, so if the column is a blank, column is equal to. Yeah, that'll work fine. We'll just need to add in these checks for categories and methods. All right, guys, I'm gonna wrap it up here and spend some time with my girlfriend. Really appreciate you guys joining me here on March 27th, 2025. It's wrap coming up on 10:30. We stream for over 2 hours and 30 minutes, 2 hours and 33 minutes to be exact. I really appreciate you guys being here. We started off with reading some of our Fluent Python. We're gonna start reading about NumPy next, so be here tomorrow to continue on with reading about NumPy and learning about a pretty key module or library in Python standard library. So NumPy is going to be really helpful for like SciPy and other things like that. And then we did the Leet code problem today. We did number 88. Was that yesterday? We did number 94, sorry. We're still stuck on 88. We did number 94, in-order traversal of a tree. And so we learned a lot about in-order traversal and got some actual practice with it now. So this was a great attempt here that we were able to do, working with you guys in the chat. It was super fun. So thank you guys, everyone, for helping me out with this one. I will probably try to come back at this one in a few days to try to re-solidify the learning and understanding of in-order traversals, especially over trees, just because trees are probably common questions that people get wrong just because they're not super studied in terms of, or common maybe. So this is going to be probably key to understand and know. But anyways, I really appreciate you guys being here for that and helping me. And then we also included and added some features to our project here. So a quick little demo. We now have a working inventory page where we can add items, check for duplicates and not allow duplicates. We can refresh the matrix, and then we can search for specific line items via their category and values of that category. And then this will also, pull up multiple instances of values if they have the same value. So as you can see, I'll search for size medium. We have 3 size mediums in the inventory. And now we are also applying this to the expenses as well. We have now a working expenses tab where we can add in expenses, refresh the matrix, and also search for those expenses via those categories as well. So it's really cool, or those columns. And everything is working appropriately. We just need to add in some checks to the categories and methods to ensure that the user isn't adding in additional information here rather than because I didn't realize they can type in here rather than just selecting the drop down as well. So we'll have to add in some checks to make sure the user isn't accessing information beyond their allowance. But other than that, this is pretty good and pretty cool. So I really appreciate you guys being here and hanging out with me so far. I stream every single day around 7 p.m. PST. Please leave a thumbs up on the stream if you enjoyed your time here and hanging out with me. It really helps YouTube to keep pushing us along and promoting us and keep growing. I have a Discord link down below where you can access all of my resources, from the books I'm reading to projects to weekly updates of courses I do and have taken, all for free in the Discord, and you can chat with me offline there. Anyways, I'll see you guys later. Thanks so much for being here. I'll see you guys tomorrow. Chat with me in the Discord. Peace out. I'll vibe with you guys for a second. Hold on. All right, we'll end up there. See you guys. Have a great night.